Hey guys, this is the second set of notes for the weather chapter, and this is going to be on air masses and fronts. Obviously, these are the actual weather systems themselves that we're looking at when we talk about air masses and fronts. So what are the characteristics of air masses, and what are the different types of fronts that follow from these air masses moving around? So that's what we're going to talk about with the weather. Okay, so what is an air mass? It's basically a body of air with the same temperature and humidity conditions. So it will be either warm, cold, or wet or dry, depending on where they form. And that's the big thing. So where it comes from is going to determine what the air mass is like. So obviously, colder air masses will come from the north of us. Warmer air masses will come from the south. And then whether or not they form over the ocean or land will determine if they're wet or dry. So these are the different characteristics that can dictate our weather. So examples, okay, so the different moisture conditions. So once again, we give a name to this. So if it's a dry air mass, we call it a continental air mass. If it is a wet air mass, we call it maritime, right? And we always think of, with continental, I like to think of Canada Dry Ginger Ale, so continental dry. And then maritime, I like to think of marinas, boats, so maritime wet. Okay, and then temperature, tropical. So think of palm trees, that's always warm. And then polar or Arctic tend to be cold, so you think of polar bears. So polar tends to be pretty cold. Arctic means it's really, really cold, right? And we've had Arctic air masses a couple times. They call them polar vortexes when they come down from the Arctic area. And we've had that condition a couple times, not this past winter, but maybe a few winters ago. We've actually experienced those. Okay, so we take those two conditions and we mesh them together. So a maritime tropical air mass, maritime means wet, tropical means warm, so it's a wet and warm air mass. Okay, a maritime polar air mass is wet and cold, because again, maritime wet, polar cold. Continental tropical is dry and warm, and continental polar, remember continental is dry, and polar is cold, so dry and cold. Okay, and where they are located in the United States. Remember, they are forming over the area to get those conditions. So maritime polar are going to be over the cold areas of the ocean. So northwest of us and northeast of us, you're going to have a maritime polar air mass here and over here. Okay, then we have a continental polar. That's over the country of Canada. That's why I said Canada Dry Ginger Ale. That's a good way to remember. And then continental Arctic is one we left out, but that would be above here, above Canada, maybe up towards the Arctic Circle. Again, those come down to us occasionally as polar vortexes. Okay, and then southwest of us, we have the maritime tropical off the coast of California and Mexico. And then continental tropical over Mexico, because that's warm and dry. And then Gulf of Mexico and off the coast of Florida, southeast of us, is a maritime tropical air mass also. All right, and these do have symbols. What they are, the first letter of the symbol is always going to be lowercase. So when you do these, it's going to be a lowercase m, uppercase p for maritime polar. Okay, continental polar is going to be lowercase c, uppercase p, and so on. Okay, so why do the air masses move? So in general, there are winds that generally move around the planet and push these systems around the globe. So we call these jet streams. These are strong winds high up in the atmosphere. So the air masses are always going to be moving east to west across the United States, and therefore our weather will actually be moving west to east across the United States. So we could always look to the west to look like what our weather is going to be like for the next few days. And that's exactly what we do. But we have to follow which way it's going to steer by looking at these jet streams. Because sometimes they'll drop further south, sometimes they'll come up further north, and that will steer the weather systems in different directions. And also whether or not it's a polar jet stream, which is a colder one, or a subtropical, it's going to be a warmer one. So that's going to bring either warm or cold air to our region, which could be a big factor when you're dealing with snowstorms especially. Okay, what happens when air masses collide? Weather fronts form. Okay, so what does that mean? Well, they're different, so therefore you're going to have clouds forming, and sometimes you can get rain or snow depending on temperature. So a front is a boundary between the air masses. The air masses are very different on both sides of the front. And what will happen in between, you'll get cloud formation. And that's what will bring your weather conditions that we worry about sometimes. So an example of that, warm front is my first one I want to talk about. That's basically when a warm air mass overtakes a cold air mass. And the warm air mass will come up the cold air mass gently and make a ramp sort of shape. As a result, you get these thinner clouds, but they're actually very long. So the conditions you get from a warm front are clouds and light precipitation. So light, steady rain, sometimes showers if it gets divided up, but generally light precipitation, not heavy stuff, but definitely more steady like usually. So these are the rain systems that kind of stick around with us. They don't go away. Might be raining all day. The next type I want to talk about could be the dangerous one potentially, usually. Cold fronts. These are the ones that a cold air mass overtakes a warm air mass, and these develop your storms that you worry about. So basically it's a wedge shape that pushes in. It forces the warm air up quickly, and you notice the clouds are enormous. So the result is clouds, storms, and heavier precipitation. We can also get thunderstorms, which you guys know, tornadoes from these. So these could be potentially strong storms from these cold fronts coming through. And they tend to move very quickly compared to a warm front. Stationary front is when a front basically stalls out. The warm and cold air start opposing each other and pushing against each other. So they meet up in the middle, and the clouds that have formed already stay put. And the front does not end up moving. And it will just stay with us until it finally starts moving again. And that could be in the matter of days sometimes. So clouds and precipitation, just like the other fronts, depending on which front stalled out, whether it was a warm front or a cold front, will determine the weather conditions that stick around. And lastly, if a storm keeps developing, we get what's called an occluded front. So the cold front, remember, which is moving faster, catches up to the warm front. And as a result, you end up with clouds and heavy precipitation, and now a well-developed storm, which actually can span many states. So the one that actually affects us during the winter, typically the nor'easter, a lot of times are occluded fronts. And they're coastal storms. They come up the coast and they bring usually big snowstorms for us sometimes, or just really windy and heavy rain sometimes. Okay. During the summertime, we get thunderstorms from these, typically, along with the cold front part of it. So the cold air comes in very quickly during the thunderstorms. And here are the symbols they use on the weather maps. So you saw those on the first set of notes. So the half circles with the red are warm fronts. The triangles that are blue are cold fronts. And occluded fronts are usually pink, and they are basically triangles and half circles on the same side. And then stationary, you'll have triangles and half circles facing the opposite direction, because again, the warm and cold air are opposing each other. And just so you know, the way the symbols are facing tells you which way the front is moving. So whatever way they are oriented on the map, north, south, east, west, northeast, southeast, you have to look at that and you'll tell which way it's moving on the map. Okay, and I do have a map video that I could post on Google Classroom on fronts, just to kind of explain this more so. All right, so hope you guys are doing well with this, and keep on moving forward.